everyone. It's time to talk about the Retrieval-Augmented Generation, aka RAG. And for those that are not familiar with, don't worry, I got you covered. We are going to start talking about the typical large language model challenges, and then trying to find a solution for that, and then use that solution to improve our search experience. So let's start with the motivation. Does anyone here like space, planets, astronomy? Okay, right, that's a good start. So, does anyone know what planet has the most moons? Any guess?
I think Jupiter?
Jupiter,
Jupiter.
Saturn. Okay, but why? Why do you think it's Jupiter?
I think because it's a big planet.
Yeah, that makes sense. But how many moons does it have?
I have no idea, Nilton.
Okay,
by the way, are you an astronaut or a software engineer?
Kind of both, I guess. So, if you don't know how many moons does it have, why do you are saying that it's Jupiter? Because if you don't have source, it doesn't seem reliable to believe in you. So this also applies to an AI model. So when we are asking for something using ChatGPT, Gemini, or whatever, they are not providing sources. So this is the first issue that we are trying to solve, because we need to have a way to find the source to check if this is a correct answer. And there's another problem that is also related to that, which is sometimes we run out of data because we have a cutoff time when the data was trained for that the AI model is using to provide the answer. So these are the problems that we are talking now, that we are trying to fix somehow, or at least prevent that to happen, because sometimes it's going to provide us some answers that's going to frustrate us, or in that case, an influencer that asked ChatGPT if she needed a visa or not to go to Puerto Rico, and ChatGPT said no, and she lost a flight. So we don't want that. We need a way to have sources. We need a way to have more accurate answers. So what we are going to do? There's a simple drawing that we are showing here, illustrating how it's going to work when we are interact with an AI model, which is basically a user asking for some information. And the AI model, based on their parameters, based on their trained data, is going to retrieve some information for you. In this case, Jupiter. But it can be reliable or not, because we are not providing a source. So how can we fix that? Instead of just relying in the AI pre-trained data, we are going to add a new layer to that, which is going to be a content store, which is basically more data. It can be available on the internet, it can be closed, it can be a bunch of documents, policies, whatever. So it's just more data that's going to serve us as a grounded source. So instead of just relying on what the AI model knows and what they were trained for, the AI model is now going to the content store to go and talk, hey, give me the more related documents to the user question. And then I can bring to my pre-trained data and give a more provided answer, which in this case is Saturn, the correct answer. So this is the way that we are going to prevent that to happen. And that's why we are seeing that a lot of media companies is selling their data to AI companies, because they are using their data for, of course, build and train a bigger model that's going to provide more answers, more accurate answers. But also, at the same time, to create a content store that's going to serve us as a grounded source. So we can use that in the practical terms that right now when we are searching for something in ChatGPT, we can see that they are searching on the web, which is basically a RAG solution, a retrieval. They are retrieving the data from the internet to augment the generation that's going to you as a response. And now we can see that now we have sources. We can check and find the answers that the AI model is providing. This is happening because of the Retrieval-Augmented Generation, RAG. So what does RAG provide to an AI company? First, cost reductions. Because we don't need to train a new model because we want to add a new data, new information. We can just add to the content store, and once it's there, we can just grab the data, and we can have a way to have the answer. More accurate answers, because we are now providing the sources, we are not running out of date anymore. And high adaptability, because if a new information comes in, we can just put it in the content store, okay? And also, this information can update, can change. We are still discovering more and more moons, more and more planets, which means at some point, the planet that we know that has the most moons can change at some point. And once we update that information in the content store, we can go there and find the right answer. And also stronger data privacy, because we can rely only on user access permission. If the user shouldn't be allowed to see something, we can change the permission to not go into the content store anymore, and they don't have the answer anymore. But we are not an AI company itself. We are providing experience. So how can we use that solution to improve our search experience? Oops. So where should I start? This is the basic RAG architecture. Tibor already talked something related to some points that we are covering right now. So we are not deep diving into the way that we are searching for the information. So please check out the Tibor talk. That's going to help a lot. So now we are going to find the documents that we want to provide the better answer. And then we are going to encode them using an embedding model, which is basically going to retrieve us a lot of vectors representing the information. And then we can store in the vector database, which is going to be our content store. And once it's there, the user can query for some information. And then we encode the query that the user wants the information, and we can run a similarity search to find for the most similar documents to that query. So if the user are searching for moons, we can find the documents that are related to moons. So if you have a better similarity search, if you have a better way to retrieve the information, you are going to provide a more accurate, a better response, okay? And once you have the documents most reliable, most similar to the query, you can go and put all together to an AI model. And then we instruct them to use all the documents that we are providing to it. And then we have our response. So this is basically the whole architecture that we are using to improve our search experience. Okay? So this is our solution. It injects relevant real-time information into prompts, and if you have a new information, you just need to put in the content store. Enables response based on internal enterprise knowledge, because AI model maybe don't know what you are serving in your website, in your solution, but you can put in the vector database in your content store, and if you are finding the documents and sending to the AI model, they will be able to give you the answer. And also, last but not least, reduce hallucination. Because we are not relying on what the AI model knows, we are relying on our own documents, the own content store that we have. So this is the whole solution, but we need to see how it looks like. And Jose is going to show you how it looks like and how it works, and who can use that kind of solution. Okay?
Thank you, Nilton. Thanks, everyone. But who can use RAG? The shorter answer is an enterprise that values speed, accuracy, and efficiency to assess it, and it's our information to deliver to the user. So, for instance, documentation portal, Wix, FAQs, internal policy slides, HR, we can ask a specific demands for specific countries, specific law, according with specific laws. So custom portals, imagining the information from the tickets we are opened by customers, the solutions, the issues, troubleshootings is a rich content to be stored in our ground source database. Common use cases, scattered or hard access the content. It means information overload in dispersion, and the high effort required to find accurate information. It means the process of retrieve precise and verified answer is tough. How many of you know Liferay? I believe most of you are familiar with our portal. It's our official documentation and education portal. So there are a lot of content there about documentation, courses, education, knowledge articles, etc. So like journal articles, Liferay objects, documents and media. It's a perfect example of how users are seek to get accurate information to answer the questions. Let's take a look. In Liferay excels two crucial areas to RAG. That's content and data management, the source knowledge, and the delivery flexibility, where AI is used. It's much better to do this using Liferay because it's easy, fast, and safe. So let's focus on documentation part, just the documentation session, the learn side. So there is a GitHub repository where the technical writers create the content using Markdown files. They send pull requests to this repository. And then there is a client extension, a cron job that reads these files. We process these files, transform them to web content, and then import into Liferay. And we do everything using headless API. So it's a custom client extension. So it runs in a separate JVM. So we do everything using a headless API. Oh, next. Okay. So we are the proposed architecture. We keep the first part, but we added two more services. One Spring Boot client extension that is responsible for embedding and semantic search. The embedding, the embed is the knowledge preparation. We are curating the content we are feeding the ground source. We split the documents in smaller documents, and then we store in the cadence. It's our vector database. And then we do a semantic search integrating with Vertex AI, with Gemini. So let's take a look in our code, in our demo. Oops. Okay. Okay. In our Spring Boot, we have this rag REST controller. And there are 3 methods, but let's take a look. Let's focus on input document. So it's responsible to receive the document and build a document that we mapped in our database vector. So these fields that we mapped here, asset entry D, asset entry type, the content, description, friend URL path, and name, we can define according to your necessity. It's not necessary to be these fields. So for our necessity, for our showcase, our use case, we define these fields. And then we invoke the rec service here. We receive this map. We delete existing document in our vector, and we define the maximum content length here. It's not a magic number, it's an empirical number, so it's different for each application, so we resolve to use this number according with our tests. And then we persist in our vector store. We are adding more content in our ground source. And the second one, the search. The search method will receive the question, the prompt from the user, from the UI, and submit. Yeah, positive. And submit to this search. So according with the similarity that we define here, we define the top K documents that we retrieve from our ground source. In this case, we are defined 4, but we can define whatever we want, and a threshold for the similarity. In our case, in localhost, we have no documents for now, so we define this value.
Remember that we don't have a magical way to do that. It's thing that is going to work for your data. So we don't have like a magic formula that's going to serve and works for all the kind of needs. You just need to see what's going to work for you, because you should know what your data is. So now we can...
Yeah, and then we retrieve the documents that were the reference documents, build the prompt. Here in the prompt, let me open this file. We have the instructions to the chatbot. In the markdown file, read this markdown file, submit to the chatbot, and then we provide the answer to the user. Oops. Okay. So now, in localhost, I have a Liferay vanilla, an empty database in K-Trend, so there is no documents there. So created an object. In this object folder, DEFCON 25, just knowledge article object. And there are 2 custom fields, one rich text, the content, and description, one text. As you can see here, it's empty. Let me open the definition. And I create 2 actions, on after add and on after update. So once we add one entry here, we'll trigger a client extension, one action client extension. Let me show you. Object action REST controller. So you do a post. So in this method, we will process this document. We will extract the information that we need, that we want to persist in our database, vector database in K-Trend. And then we will persist there. So I have For that, let's do a search query asking, where is Liferay DEFCON 2025? I'm using Insomnia here. I'll do this get. Internet connection. Okay, no content was found because we have no information. So it won't search on internet, it won't hallucinate. So let's create a document here.
Excellent.
I have this content. I will add this object entry. Save, we'll trigger that class extension. This action will be triggered. And let's take a look in cadence. Yeah, now we have a document there. And let's do again the same query that we did. Where is it? Yeah, so now we have an answer. It's not the same content here, but it creates an answer based in my prompt. So let's take a look in Liferay Learn. So here we have documentation, course, certification, learn paths, but let's focus on the documentation part. I will authenticate here. Yeah, this search is based in keywords. So the user is not able to ask questions and to be answered for a chatbot, for instance. But we create a fragment. So I will, I have some queries here. For instance, if I ask how to upgrade, how to auto-upgrade Liferay database, we still have the document here, but once I submit here, we create just a simple Liferay fragment that will consult our vector database, not locally, but in the cloud, and we'll have this answer based in our ground source.
Based on the retrieved content. Exactly. So once you get the right information related to the user question, you'd be able to serve the AI model with the information that they should use to give the answer for the user. So right now, instead of looking for each document that we have on Learn, we can just ask a question and take a look at the summary provided by the content that is on Learn. So instead of, because Learn is always updated daily basis. So we are releasing new information every day. So instead of just relying what the AI knows or what the AI was trained for, we can use the documentation that's already available on Learn to serve and retrieve a new information related that you were looking for.
You have the original documents here. If you click here, the reference documents that was more similar with our results, and the chatbot built our response. Let's do another query here. So everything runs on SaaS, so there is no custom with GI modules. And in our UI, we just create a Liferay fragment. And you can see the documents.
Remember, you can use whatever AI model that you want. You can use whatever embedding model that you want. You just need to be careful and take a look how the retriever is going to work. You can use standard embedding models such as BERT, Word2Vec, or like AI models that we are using right now. We are using Vertex embedding model. So we can do the same or do different. You should use what fits better for your data.
Yeah, and this is a simple library fragment, a simple HTML, and a simple JavaScript. We manipulate it, and a simple CSS. And that's it, guys. If you are questions, comments, thank you. We are here to answer questions during the entire day, tomorrow in the conference, so we'll be glad to listen you to talk a little bit about that. Thank you very much.